Hi, everybody. My name is Tyann Rowland. I'm the Extension Educator in Adams County in Council, Idaho. And today we have Eva Strand with us, an Associate Professor with University of Idaho, to talk about wildfire and fuel treatments in sagebrush ecosystems. And Eva, if you would introduce yourself just a little bit more, that would be great.
Absolutely. Thank you so much, Tyann, for inviting me to speak to your group. So my name is Eva Strand. I'm working up in Moscow, Idaho at the University of Idaho in the Department of Forest, Rangeland, and Fire Sciences. And most of my research is done in sagebrush steppe and juniper woodlands and aspen woodlands of Idaho. And I've also worked some on forest and fuels in other ecosystems. But sagebrush is really and juniper is really where my passion is. So that's what I would like to talk to you about today, because there has been a lot of change in what's going on with fire in Idaho and in the Great Basin in general. So I get my support, of course, from the University of Idaho. I also am involved with the Sage Step project. I get funding from the Joint Fire Science Program and also from the Great Basin Fire Science Delivery Group. Those are great people that support me and my research and also provide science delivery for what I do. So I'll just go ahead and get started. First of all, thanks so much for everybody for coming. So we're all living in the kind of Idaho is in the northern part of the Great Basin, and some of Idaho is also in the Columbia Plateau. But the main ecosystems or vegetation types that we have is the salt desert shrub, which is, if you have been down by south of Boise, for example, in Grandview, that area is dominated by the salt desert shrub. It's a pretty small area in Idaho. Then we have large portions of Wyoming big sagebrush. That's all along southern Idaho, down by Twin Falls, Idaho Falls, and areas, the whole southern part of Idaho, really. And then mountain big sagebrush at the kind of the same general area, but higher elevations. And above that, we have areas dominated by mountain shrubs, also getting into juniper woodlands and some mesic shrubs. So all these vegetation types occur along temperature and precipitation gradients. So if you go from the left to the right on this graph, it goes from more wet or mesic to more, for the drier areas to the wetter areas. So the dry areas are less than 12 inches in precip, and then up to 16, maybe even more inches of precipitation per year. And this is a map of Idaho as part of the Great Basin vegetation and the sagebrush types that we have here. And there's more than 20 different species of sagebrush, and this map only shows the main ones. So one of the main higher elevation ones is the mountain big sagebrush. Lower elevation in the green here. Of course, lots in Wyoming and also in southern Idaho is the Wyoming big sagebrush. But we also have three-tip sagebrush, especially up in Washington state, but also in southeastern Idaho. And black sagebrush is in the more dry areas in Nevada. So lots of different sagebrush types, lots of different plant communities that come with that. And fire also impacts these ecosystems in a different way. So Gene Chambers and others Gene works in Nevada in Reno for the Forest Service, although recently retired. She and her colleagues have mapped the categories of sagebrush into those that are more resilient to wildfires, so they don't react so much. They recover more quickly from wildfire, and they are more resistant to invasive species. I'm sure everybody on this webinar have heard of cheatgrass, for example, these annual grasses that come in and replace our native vegetation. So she has mapped the Great Basin and associated states and also on the Columbia Plateau into these categories of areas that are more resilient. Those are the blue areas. They recover more quickly. If you have a fire, they won't be they won't be they recover more quickly, I should say, versus the yellow is the medium and the low is the areas that really have a hard time recovering and may actually be converted to cheatgrass and annual grasses if we have a fire, more susceptible to that invasion. So what we've seen over the past few decades is that we've seen really a change in the way that wildfires work. So the number of wildfires have kind of stayed the same or even decreased because we have more efficient firefighters. But the area burned has actually increased and is on an increasing trend, which means that we are having more large fires. So there's an increase in these large fires. And I think I have a list here. So these are sometimes they call them the mega fires, the fires that are more than 100,000 acres in size. And this is just a list of fires. You might be familiar with some of them. One that affected my life was the Murphy complex in 2007 that we did a lot of studies on. It was over 600,000 acres, which was a size that really was unheard of at that time. Nobody could believe that we could have a fire that big.
I
So
think the
fires,
soda fire is the one that really sticks out in people's mind as being one of
oh,
the larger ones recently in Idaho that
yeah,
was
the
attended.
soda fire. Yeah, almost 300,000 acres and almost got to Marsing, Idaho, almost impacted the town.
Mhm.
And it was closer to your area as well.
It was,
It's
yes.
yeah.
Um, I'm not exactly sure where the sheep fire is the one here that's marked as 2019. Do you remember what area that was in?
Oh, this is a map of 1984 to 2018 of looking at fires that have occurred. And we can see that a fair share of them are really occurring in Idaho. And this is a map that I try to show as often as I possibly can. This is a map of historic burn probability versus the current burn probability. And the areas that are in blue and green are the areas that are actually still receiving less fire than they did historically. So many forested areas, for example. But the areas in red and yellow are the areas that are experiencing more fire than they did historically. And you can see that many of those areas are in Idaho and in the Great Basin in the sagebrush habitat types. This is just a look at southern Idaho, 1950 to 2019, and all the fire perimeters piled on top of each other here. And you can see that many areas burn, but also see that many areas burn frequently. They burn multiple times. So if you look at all the fire perimeters there, they're close together and the same areas burn over and over again, which they didn't really used to do. So another thing that I do want to point out, that fire is a natural part of our ecosystems, of the sagebrush ecosystems. In the past, we always had fire, and fire had a function in the systems. So I just want to point out that at first, so nobody thinks that, yeah, we just want to get rid of fire, because it has a function. So it does maintain, uh, it maintains sagebrush by reducing the encroachment of ponderosa pine, Douglas fir, western juniper. If you are from an area where western juniper or a juniper species is expanding into, you might see that the sagebrush and the grasslands are replaced by these woody species. And fire in the past used to take care of that by reducing those woody plants. Sagebrush or fire also maintains the grasses. So the grasses and the forbs are an important part of our sagebrush ecosystems. And with periodic fires, and they used to be smaller fires, they reduce a bit of that sagebrush and increase our grasslands and our forage base for wildlife and livestock. So fire is beneficial in that regard. Fire also divert primary productivity away from woody species to herbaceous, so it supports our grasses and forbs. Increases forb component, I think I've already said, which is good for wildlife and for pollinators. It uses those forbs. And it also establishes recruitment conditions for a younger cohort of sagebrush and bitterbrush and rabbitbrush and all these other shrub species and grasses that occur in the sagebrush. It provides nutrient cycling and alters the fuels. So fire has a function in the sagebrush ecosystems, but it has a different function in different places. So this
I'm sorry, Ava, does it help with reproduction at all? Like some species, it helps open up seeds and pine
Yeah,
things like that. Does it do the same thing in sagebrush step?
yeah, it does. Sagebrush itself, of course, is sensitive to fire. So when a fire goes through a sagebrush stand, the sagebrush will die, basically. Sagebrush itself is very sensitive to the fire, but the grasses have evolved with fire. So it usually, unless there's a lot of woody material that makes the fire burn very hot, the grasses will survive and resprout even the following year. They'll be back.
Okay.
So it's kind of interesting that fire is a little bit setting back the sagebrush a lot, but really supporting the grasses.
Mm-hmm.
So if you are interested in having more grass, fire is often your friend, unless of course it's cheatgrass and the annual grasses that you don't want. But for our native grasses, they definitely evolved with fire and they are adapted to fire periodically. Yeah, that's good. Ask questions whenever you hear something that sounds interesting. Go ahead and ask a question. It's more interesting to have a dialogue than to just have a monologue, I think.
Okay. Well, another question I was going to ask is that I know in my area here, I've gotten a hold of the Forest Service and they've given me their seed mix that they use for reforestation after wildfire in
Okay.
our counties. And I was wondering if maybe there's a way to get a hold of some of the seed mixes that they use for regrowing some of the sagebrush areas, or even if does the BLM and state and federal land even use mixes like that to.
Yeah, they do. The BLM has a big seed storage, and also ARS, the Agricultural Research Service, they have seed services too. So, and they collect seed, and when there is a large fire that they think is not really going to recover on its own, they do a lot of both drill seeding and aerial seeding. And drill seeding seems to be quite successful. Aerial seeding is more unknown how successful that is, but the drill seeding is really successful. So there should be seed sources for the native plants that we had. And sometimes you add non-natives too. The native plants are often more expensive, but I think they have higher likelihood of maybe doing well. Yeah, there should be a lot of seed mixes available from different places, from the
I get that
BLM.
question a lot. I have people coming in asking specifically to how to support wildlife by
Yeah,
using some of those seed mixes. Um,
yeah.
I have lots of new landowners come in and ask those questions, so it'd be nice to get my hands on the mixes that they use in our area, the seed mixes, and what
It
they have in the
definitely,
seed mixes.
yeah, definitely would. And for sagebrush brush itself, it's been discovered that it really matters where the seed comes from. So if the seed come from an area that has about the same climate, it's going to do a lot better than if it is from a different area.
Right.
So that where the seed comes from has also been shown to be important.
Does it? Do
I'll,
you run into issues with in non-native species causing problems after seeding of these?
some of them do. Some of them kind of stay monocultures, and there's no other species can. There's very little for recruitment and other native species recruitment after they are seeded. So
Right.
that I think there's more of a movement towards more diverse seed mixes that maybe has a mix of native and non-native species, and more diversity in general, instead of seeding just one species that was maybe more common in the past. But I mean, we're learning. We're still learning. We're always learning,
Right.
and I can try to find more information about sources of seeds too.
That would be wonderful because it seems to me that the goal is to choke out the cheatgrass from
Yeah,
establishing.
yeah.
Really.
Yeah, exactly. And it has been shown that if you have a healthy stand of perennial grasses, cheatgrass won't establish. So, and of course, that's what everybody wants anyway. They want to have the healthy stand of perennial grasses that will come back year after year and be resilient to fire. So I will look into that. I'll write that. I'll take a note about seed sources.
Thank you.
Yeah. And I think it's pretty regional. So it's regional to wherever you are. It's important to find something that works, particularly for the climate where you are in that region.
The local offices must do a lot of seed collection then for their own local areas, I would think.
I think they do. Yeah. And hopefully they get labeled really carefully so
Right.
they know which, yes, they will be suitable for. Yeah.
Okay.
Yeah. I'll see if I can find more information about that. So another thing I wanted to point out, I know most of us, or I don't know, maybe the audience is from a variety of these habitat types, but in the drier sagebrush, we usually had lower fuel loads. So fires in the past, and this is pre-settlement fire return interval. So in the drier areas, we had less fires. So maybe even up to 100 to 500 years between fires. While if you're up in the more wet areas in mountain big sagebrush, they may only have been 10 to 15 to 20 years between fires. So it really is sensitive. The way that fire interacts with sagebrush is really sensitive to where you are. I think I'll skip this one.
Our area is definitely in that mountain sagebrush going down towards the ponderosa pines and the forest.
Oh, okay.
Really, we're really right on the cusp of a lot of our sagebrush is just right on the edge of large forest land. So
Okay.
we're right there. So yeah, I would say definitely that range of just not very many years between fires is very accurate.
That would have been what it used to be. Yeah. Yeah. So in the historically, we had this cycle of we had a grassland after fire, and then we had sagebrush coming back, and then we had another fire, and the grasses came back, and it was just this cycle, kind of grass, shrub, and also maybe in a fine pattern across the landscape. But with the cheatgrass coming in, and I don't know, maybe you don't have a lot of cheatgrass issues in the area where you are.
Oh, I'd say that we definitely have a lot more. It
You
seems like The longer that some of these places sit, of private property sitting unused and untouched, really gives a chance for weeds and cheatgrass to overtake the perennials.
Yeah. Huh.
And we have a lot of that here. We have a lot of land that sits here not used, either
Mm.
because it's state or federal land, though they do graze that fairly well here. Uh, but there's a lot of land that sits there vacant, or that nobody has, livestock on to graze it. It's not
Huh.
getting the attention that could really reduce cheatgrass from moving in. So cheatgrass definitely does show up in, oh, in a patchwork across the landscape for sure.
Sure. Yeah. Yeah. And if it does, and it can get into this cheatgrass cycle where, because cheatgrass is very flammable, it matures early and ignites easily and provides a fuel continuity. So some areas get into this cheatgrass cycle where it just burns every 5-10 years, and that's maybe more happened in southern Idaho than up where you are, I think.
Yeah.
um,
You think about the freeway there near Twin Falls, it just looks
yeah,
like a sea of cheatgrass in some
I-
places. We
yeah,
don't have that up here.
yeah, it really does. So that is good. Yeah, hopefully keep it that way. So it doesn't get into that fire cycle. But you have a lot more topography and some trees and more variability, I think. So the risk that that would happen, I think, is lower in your area. But in southern Idaho, that this is a big problem near Twin Falls, like you said, Mountain Home, that area along the interstate. You
Oh
can
yeah, it's
see it
scary.
see it happening. So I just wanted to contrast these mountain big sage and Wyoming big sage types. So the Wyoming big sage is usually at lower precipitation, 10 to 13 inches, while the mountain big sage is 13 to 16. So that's probably where you are at. But you don't have juniper up there, do you? You have more of the ponderosa pine.
Yeah, we have ponderosa pine. So we're kind of, half of my county is Wyoming big sage looking, and the other half is definitely mountain big sage looking
Okay.
until it hits closer to the Valley County borders where it turns into forest.
Then it turns into forest. Yeah.
And I grew
Yeah.
up in McCall, so I moving here, I was much more used to forest fire than I was um, more this dry land fire that moves quite a bit faster.
Yeah, it does.
Mhm.
Yeah, it moves quickly because yeah, it does because there's less fuels to burn and they're often drier, and grasses of course carry fire very fast.
Right. I was never evacuated until I moved here. And then my
Huh.
first couple of years here, I got evacuated right during our county fair time when I'm trying to
Oh
deal
my
with the
goodness.
fair. Um,
Ah,
then my
not a
home, they ask us to leave. But growing up in McCall, I had fires very close to us and we were never asked to evacuate. And it's just because they were slower moving.
yeah, and they were up in the forest. I remember some of those, the Brundage fires up there. Uh, yeah, those were big fires.
Yeah.
So contrasting these drier and wetter sagebrush, I was going to point out again what historically the mountain big sage burned more frequently, and this is just a bunch of literature references, but all of them kind of say that it used to burn maybe 10 to 20 years between fires in mountain big sage, so pretty often, while the Wyoming sage was more like 50 to 100 years. So it's a big difference between these types. But what has happened lately is that these have basically flipped. So, thanks to fire suppression and other reasons, we have actually less fire in the mountain big sage. So, it's become less fires there, which has often led to encroachment of juniper, and maybe in your area, other maybe pine is wandering into the sagebrush and grasslands. While in the Wyoming big sage, we have more frequent fires with this cheatgrass cycle that I just described. So it really depends where you are, how fire used to be and how fire has changed. So I'm just going to show some pictures here. So this is a Wyoming big sage. This is from southern Idaho, so it's probably more further south than you are. And this is, let's skip these actually. So there we are. And then after one fire goes through, often there are some areas left. The fire doesn't take out everything. It leaves these inner spaces with sagebrush that's left, which is important. They work as a seed source so that the sagebrush can come back. But then if you have a fire that comes back right away, you might end up with something like is mostly annual grasses and annual forbs. So that's what that frequent fires does. It takes that sagebrush system into more of an annual grass, annual forb type system.
So sagebrush seeds don't really survive fire?
No, no, they don't. Sagebrush seeds don't survive much at all. They don't live very long, even in the soil. They are very sensitive and they don't spread very far. They don't have any wings or anything that can make them fly.
That
So
was
they
my next
basically,
question.
they're small and they just fall down on the ground.
They just fall
And
straight.
yeah, they fall straight. And some people have looked at that and they blow, maybe if it's a windy day, they might blow like, I don't know, 15 feet or something away, but they don't go very far. So that's the problem for sagebrush. It's not a very good cedar and it doesn't sprout. So that's another thing that kind of goes against it having a hard time to regenerate that way. So if a large area burns continuously, it's tough for sagebrush to come back.
How long, so after a fire does burn through an area, what's the average amount of years it takes for sagebrush to really come back into the landscape and take hold again?
Yeah, that's usually in the higher elevations. So mountain big sage, that can happen pretty quickly. And I actually have some pictures of that just coming up. But I guess since I'm showing the Wyoming sage now, it can take longer, up to 30 years, maybe even more. And if the burn is really continuous and doesn't leave any seed source behind, it takes even longer. So maybe 30 or so years to get back to your pre-fire condition, and more if it's a continuous fire. But in mountain big sage, it can come back pretty quickly. So I'll show you some pictures here. Oh, this is, I don't know where this picture fits in, but anyway, this is a picture also from southern Idaho. It's 2 years after the Murphy fire. So this I would say would be not a bad fire because we have a lot of perennial grasses, we have forbs, we don't have much cheatgrass. This is a little higher elevation. So in this case, fire didn't damage the ecosystem, I wouldn't say. It took out the sagebrush, but the sagebrush will come back. But the grasses are doing great. Oh, this is another picture where it didn't work out so well. So you have a high variability. This is same fire, but 2 years later looks pretty bad. But this is mountain big sagebrush. So this is the mountain big sage Idaho fescue. This is on the Salmon National Forest. And this might be more familiar to what you're looking at near Council. Yeah, more ponderosa pine, the mountain big sagebrush. You got a balsam root there and maybe some lupin.
Yeah, very much so, similar.
Yeah. And if these areas burn, so let's see. Yeah, this is a similar area, mountain big sage, 8 years after fire. And you can see the sagebrush already coming back there, looking pretty good. And this is down on the Beaverhead and 7 years after fire. A little bit less sagebrush recruitment, but the grasses seem to be doing well. So in that higher elevation sagebrush, fire is often it recovers much more quickly than it does in the Wyoming sage. So that's good that you're up there. Your main issue is maybe the woody encroachment and that kind of problems than it is cheatgrass.
I hope so. It seems like it's an easier problem to have than cheatgrass.
Yeah, yes, it does. It actually does, because you can even put in mechanical treatments for those kinds of things. You don't have to use fire at all. So I just want to go a little bit more into the weeds here with the sagebrush and fire. So in sagebrush, you have both the woody component, which is the sage, and you have the grassy component. Unfortunately, it's cheatgrass in this picture, but it could be perennial grasses too. And the primary use or relation to fire, the primary component that starts fire is the grasses. So fire ignition often starts in the grassy part. Because the grasses dry out more quickly, they equilibrate with the surrounding areas and temperatures. They spread fire really fast, and they usually have lower intensity and severity in the grass component. While the shrubs more act as ladder fuels. They increase the flame length, they increase the intensity because there's more wood. Like if you put more wood on a campfire, you're going to have a hotter fire. So that's what the shrubs kind of contribute, and they may smolder a bit too. So this is just a picture of sagebrush. On the upper left here, we have an unburned stand that looks pretty nice. We have sagebrush and perennial grasses and some forbs. Looks super nice. And if it burns, what you usually see that right where you had a sagebrush, you see a kind of a black area, maybe a black ring around there, because that wood burned much hotter. And around it, see here, the grasses have just come up just fine around that. Where the sagebrush was. So the more sagebrush you have, the hotter the fire is going to be, and the more grass mortality you're going to have too. And you probably know April Hewlett, Tyann. Have you met April? Yeah.
Yeah.
Working in extension, and she has done some really good research on that. And this is a graph where she's looking at distance from a sagebrush. So 0, you're right under a sagebrush, and then going out where this line is kind of where your drip line is of the sagebrush. And she has showed that in a fire, it burns much hotter right where the sagebrush itself is. And you have much more grass mortality under the sagebrush when it burns than in the inner spaces. So that again kind of points towards this graph that the more sagebrush you have, the higher grass mortality you are going to have. And the drier the weather is during the fire, the more grass mortality you're going to have. And since our goal is to maintain our perennial grasses, that's good information to have. But of course, the weather is something we can't really do a whole lot about. But I'm really impressed with April's work on that. So the more resilient shrub step is really when we have a little bit, kind of a balance of grasses and shrubs, rather than a dominance of the shrubs. Okay, so yeah, this again just shows that if you look at the pictures to the left, going from up to top to bottom, the top is pre-burn, then we have a fire. So in the top image, we have mostly grasses, very little shrubs. It burns really quickly, but it also comes back very quickly. We can just jump over to the right here. If you have a very thick sagebrush before the fire, it's going to burn more hotter, longer flame lengths, higher severity, and we might have high mortality of the grasses. So this is an image. This is back to the Murphy fire, but I'm sure I could show a similar picture from the Soda fire. This is a burn severity map, and the red is high severity. So that means a lot of mortality of the plants. Yellow is moderate, and these kind of turquoise is low mortality, and the green areas within the fire perimeter that didn't burn at all. And when this Murphy fire happened, a lot of researchers kind of looked at this map and they thought, well, what's going on? Why are there some of these areas that haven't burned, that are unburned or have really low severity? What's so special about them? And it became pretty clear when we overlaid that with historic fire perimeters. We could see that areas that had burned pretty recently and removed some of the shrub component burned at much lower severity. So that kind of shows that fire, and they also had been seeded. So there was seeding going on in those areas. But we can see that fire is a natural part and used to burn these. You can actually, this map is pretty cool because you can see how small these fires are in the past. There was like 15 fires in the area that burned in one single fire in 2007. So historically, fires were much smaller than they tend to be now.
It's really interesting how they're all just almost exact little circles around those blue and green areas. And
Isn't it? Yeah, it really is. It's very striking. Yeah, this little one here, 1996, just a circle that area didn't burn. So that area probably it had pretty recently burned, so had less shrub cover and maybe had been seeded with grasses as well.
even the little fingers coming off that 1999 fire next to it.
Yeah,
The
yeah,
blue,
yeah. You can even see the fingers.
Yeah.
That is pretty crazy that it is that good of a fit. And I didn't even run any data on this. This is just a visual overlay that to see it. So let's see here. We'll continue a little bit. So should we talk about treatments too? Is that relevant to this group, do you think? I could talk a little bit about it maybe.
Yeah, or even just what's available out there for treatments.
Yeah, I'll do that. So there is a project that's called the Sage Step Project, and they are looking at, what kind of treatments can you do and they're looking at both sagebrush and also the woodlands. So mostly juniper woodlands in the Great Basin, where the juniper is expanding into the sagebrush. And they're looking at, how can we promote the perennial grass growth and the forbs and the diversity in these systems. And the treatments that they have been looking at are, they've done some mow treatments, and that was done in sagebrush with the goal of increasing herbaceous, so increasing grass and forb. And then they did prescribed fire, which is a risky thing to do in many areas, but people do prescribed fires. Then they, of course, had a control where they didn't do anything. And then they also added herbicide to some areas to, especially would be important for areas that have a lot of cheatgrass. If there's not a big cheatgrass component, that probably wouldn't be important, but the chemical there, tibuthyron, is used for annual grass control. So these were the treatments that they tested. And they also did, wrong. Tibuthyron is for actually for sagebrush treatment. So if you want to try to thin your sagebrush, the imazapic is for the annual grasses. So some chemical treatments. And this is a lot of information here. Let's just look at the top graph and look at how the fuels changed. So in the control, so Sage Step has been going on for a long time, been going for 10 years now. So in the first bars here, you can see that fuels in the controls didn't really change over time because nothing was done to it. They didn't burn it, they didn't mow it or anything. While in the fire treatment, that's the next few bars. I'm pointing at them right here. You see the control is the same year zero, but then the fuels were really reduced after the fire. But the grass component is the dark green, increased. Mechanical treatment didn't reduce the fuels as much, which if you're just kind of mowing it, you leave all your fuels on the site, so that doesn't change. And the chemical treatment didn't really reduce fuels at all because the wood was still there. So if the goal is to, I think the kind of the what we learned from this is if you want to reduce your fuel loads, fire is the most effective, prescribed fire is the most effective one. But of course, it depends on if you can apply it. It's much maybe harder to get permits to do that. We decided that the tibiothyron treatment didn't really work very well. So there's a paper coming out on this here pretty soon. But then what people really were interested in was the fire behavior. And I'm not going to go through all these graphs, but I'm just going to say, so we have year 0, year 1, 2, 3, 6, and 10. And if you look at the rate of spread, the prescribed fire treatment really was the most effective one. And mechanical was the next to effective one. And tibiothyron wasn't really effective at all. And after 10 years, you were pretty much back to where you started. So the treatment lasted for about 10 years. And that was for rate of spread, and similar information for flame length and intensity. So I'm not going to go through those because they were about the same. So maybe, do we have time to talk a little bit about targeted grazing?
Oh, absolutely.
Okay, we'll do that. As your time ends at 8 o'clock, is
We have
that
about
kind of
15 minutes left.
we're shooting for? So I'll go through some of these. So this is a project that I did with my master student here. This is Chris Schack-Snyder, and also other people involved is Karen Launchbaugh, who you might know, and Scott Jensen, who works down in Marsing in Extension. And we did a targeted grazing treatment where we were interested in looking at, well, how can grazing change fire behavior? How can grazing change fuels and fire behavior? So that was the question. So we had the cow grazing, and we were working with a rancher down in Reynolds Creek. So the first question was, can livestock grazing affect the fuels? And of course, we think they can, because we know that they remove the grassy biomass, and they probably don't do very much to the shrubs. And then the second question was, can livestock grazing affect fire behavior? So flame length and rate of spread. And this area was in Reynolds Creek, so south of Boise. We had set up these plots, and we had 3 plots in mountain sage and 3 plots in Wyoming sage. And this is just showing some of the pictures of the area. The Wyoming big sage had really high shrub cover, very low grass cover, a lot of annuals. And the mountain big sage site had actually burned pretty recently, so it had less shrub cover, much more herbaceous, much more grasses and forbs in the mountain big sage. So the top picture here, that's the Wyoming big sage. You can see high shrub cover, actually lots of cheatgrass in the understory, and not much grass at all in the understory. And Wyoming, in the mountain big, we had much greener, more grass, less shrubs. So the plot design was that we looked at one area had no grazing, and then we had 2 areas that were grazed at peak biomass, one at 30% and one at 60% utilization, and then a dormant season grazing, so fall grazing at 30 and 60% utilization. And then we actually measured the fuels, and we actually burned these. The BLM helped us burn this. That was an interesting day. So we did a controlled burn, and this happened right after the soda fire. So for a while they said, no, we're not going to do it. There's been enough fire. We're not going to do any prescribed burning. But they did help us burn our plots because we'd spent all the time. Chris had been there for 2 years and preparing them with the heifers and grazed them just right and everything. So there was a lot of work going into it. So we did burn them. And this is the results, and I'll go through them real quick. I'm just going to go through these top two here. So for the mountain big sage, of course, we saw a reduction with grazing with when compared to the control. The cattle really did remove some of the grasses, which is totally expected. In the mountain big sage, we saw that. In the Wyoming big sage, though, there was so little grass to begin with that there wasn't much grass for them to eat. I don't know what they actually ate when they were in there, but
It
there
doesn't
was a
seem like
little bit
there
of
was a lot of good stuff in there for them.
there was not a lot of good stuff in there, but they removed about as much as they were supposed to. But I'm sure they weren't. They would have They would have been much more happy up in the mountain big sage.
Mhm.
But what we saw relating to the flame height is that, so here we have shrub cover on the x-axis here, going from 0 up to, the graph goes up to 80, but it was really only up to 60. And we can see that when we have low shrub cover, we really have much lower flame lengths. And we have, when the shrub cover gets high, we have much higher flame length. So the flame length is really mostly dependent on the shrubs. And the main results from the study was that the grazing does reduce fuel loads and convert some of the standing biomass to litter. There's no change in shrub cover, which we didn't really expect. No difference we didn't find any difference in fuel loads between summer and fall grazing. And we're still kind of working through this data. So I hope we're going to publish this pretty soon. And we did see a reduction in flame length and rate of spread at low shrub cover levels. And we actually also saw a little bit of reduction with the grazing, comparing the control. There was a significant change in flame length with the grazing compared to not grazed. And I'll just finish up with this slide right here that shows us that, so we kind of starting to think about this. Well, when can grazing actually be effective at reducing fuels and fire behavior? And on the x-axis here, we have the fire weather. So on the left, it's kind of mild weather, not very hot, pretty moist, versus on the right, it's extreme fire. It's super windy, high temperatures. And at those situations, we don't think that grazing can do very much because it's totally driven by the weather. And we also think that if the sagebrush cover is really high, the sagebrush is going to drive the fire behavior. So where grazing really can have an influence is where we have kind of more moderate weather and less shrub cover. That's where grazing can be more effective. So I think that's the end of what I was going to talk about. And of course, if there are questions, if people have questions later, since many weren't able to attend, they are more than welcome to email me, or if they email you, Tyann, and you contact me and compile questions, that would be great.
Yep, I will do that for sure. Well, I think I've asked all the questions I had while you were speaking, so.
Okay, yeah, it was nice to have a conversation. I really enjoyed that instead of just talking. It's nice to have questions come in as we go.
I'll never
And
remember to ask the questions at the end.
I know, yeah. And Chris Schacksnyder, the grad student, he now works in Pendleton. He works for Extension. So that's really great. I need to talk to him here one of these days. So, but it's great to have our students all over the place and doing good things.
Well, thank you so much. I will go ahead and I'll post this to my office's Facebook and to YouTube under the unlisted so that someone can
Yeah,
ask for it instead of having it public. But
yeah, that's great. I usually do that too, unlisted. Thank you.
all right. Well, then thank you so much for taking the time to do this with me today.
Yeah, thank you and have a good night.
Okay, you too. Bye.
Bye bye.